Okay, I'm back, and so now we want to talk about the Coriolis Force. And so before I tried to explain it, it would be very, very good if you were to watch this video here. So this video is entitled Coriolis Effect by National Geographic. So go to the internet, go to Google, type that in, and you should see a picture of some people on a merry-go-round. Alright, so watch that video. I'll wait. Okay, did you watch it? Alright, so let's talk about what you saw on the video. So you should have seen 4 people on a merry-go-round. So you had a person here, and one's here, and one's over here, and then one's over here. And so this person is going to take a ball, and they are going to throw it straight across to this person over here. No problem. Okay, so that's Newton's law of motion. An object in motion tends to stay in motion and go in a straight line. So trust me. So that's from physics. Okay, now the next thing that they do though is they take the merry-go-round and they start it rotating. This person tries to throw it in a straight line to this person over here, but according to them, they see the ball do this, and it ends up with this person over here catching the ball. And so it appears to the person who is on the moving merry-go-round that the ball curved in the air as though there was another force acting on it. And so we're going to call that the Coriolis Force. The Coriolis effect was what did it. But then they showed from an aerial view what happened. Okay, so from an aerial view, from the point of view of somebody who was not on the merry-go-round, what they saw was the ball went in a straight line, but by the time that the ball got over to here, the merry-go-round had rotated so that this person ended up catching it. So according to somebody on the moving reference frame, you see some things curving as though there's an extra force acting on it, when in fact there's not. So it's kind of like an optical illusion because that you're on a frame, in a frame of reference that is rotating around and around. Well, what on Earth is rotating? Well, the Earth is. So as the Earth is rotating, and now let's say that you've got a wind system. So now let's draw the Earth like this, and let's say that there's a wind system that is trying to blow due south. Well, because of this Coriolis force, it's going to be bent, just like it was bent here, and it's going to be bent to the right. So winds are going to be bent to the right in the northern hemisphere, and winds are going to be bent to the left in the southern hemisphere because of this Coriolis effect. So that as a wind tries to go south, what happens is it's going to be bent in this direction. If something is trying to go north, like that, it's going to be bent in this direction. So it doesn't make any difference which way that you're trying to go. You're going to always be bent to the right in the northern hemisphere, and you're going to be bent to the left in the southern hemisphere. So here is a formula for you which you don't have to worry about. Okay, so there's a formula if you actually wanted to calculate the strength of the Coriolis effect. It depends on that T-looking thing, which is one of these things. So that is the period. So that's going to be how long does it take an object to spin. So that's the period. You'll also notice it depends on the mass, m, of the thing that's moving. It also depends on the speed of the thing that's moving. And then finally, it depends on what latitude you're at on the Earth's surface. So all of those things go into play when you're actually trying to calculate the Coriolis force. You don't have to do it. So all I want you to know is what is it, and then what causes it, and what does it do to wind systems. So that's what you should know if you're taking one of my tests. So how is this Coriolis effect going to affect global wind systems? And we'll talk about that in our next segment.